Hello friends, in this video I will discuss what is differentiation and few formulas to differentiate. First, let's understand what is differentiation. The rate of change of a quantity y with respect to another quantity x is called the derivative, and the process of finding derivative is known as differentiation. This is the definition of differentiation. It is usually represented by dy by dx. There are also other forms to represent, such as y dash or y1 or dy. This all mean the same. They are just the different forms of representing differentiation. Let's understand this in a better way. This is a graph. This is the y-axis and this is the x-axis, and let this curve represent one of the functions. And so if we want to find slope of the curve, we cannot find because it is not uniform. Let's say we want to find slope of this graph, so we connect 2 points. So this will not give us the accurate slope because the line is a curved and not a straight one. So slope is variable at all points. Now you would say that we can take the point still nearer. So let's take a point over here and connect these two. This is still not accurate. We want the most precise value. So we should plot the second point exactly near to it. And when we do this, the line which comes is tangent to this. And when we find the slope of this line, we find the instantaneous rate of change at this point. That gives us the most accurate result. That's why we use differentiation. Now let's switch on to some formulas for differentiation. Differentiation of any constant value such as c is equal to 0, because a constant value cannot have a rate of change, so it is 0. Let's take one example of it. D by dx of 9 is equal to 0. This is the first formula. Second formula, d by dx of kx, which will be equal to k. Let's take one example, d by dt of 3t, which is equal to 3. So when a constant is multiplied by x and we differentiate it with respect to x, it is equal to the constant. D by dx of x raised to n is equal to n into x raised to n minus 1. D by dt of 5t cube is equal to 5 into t square. Fourth formula, d by dx of e raised to x. Here e is the Euler's constant, and when we differentiate it with respect to x, we get the same as answer. And this does not require any example. D by dx of a raised to x is equal to a raised to x log e to the base a to the base e. Example of this can be d by dx of a raised to 3 is equal to a raised to 3 log e a to the base e. Sixth formula, d by dx of log x to the base e is equal to 1 upon x. Example, d by dx of log e log 3 to the base e is equal to 1 by 3. D by dx of log x to the base a is equal to 1 upon x log a to the base e. An example of this can be d by dx of log 5 to the base a is equal to 1 upon 5 log a to the base e. Now let's take some more proofs. D by dx of sin x is equal to cos x. And ninth one, d by dx of cos x is equal to minus sin x. 10th one, d by dx of tan x is equal to sec square x. 11th, d by dx of cot x is equal to minus cosec square x. D by dx of sec x is equal to sec x into tan x. D by dx of cosec x is equal to minus cosec x into cot x. These are the formulas, and each one has a derivation, but we are not going into deep. We are just understanding the formulas. So these are the 13 formulas, and you need to remember this.